the request of the organizers, the topic was totally different. I'm supposed to talk with the request of the people who have organized this program in an area where we are looking for people to work on collaborative research. I'm basically from DRDO, and till today after my retirement I'm very much connected with DRDO in various capacities, and have also brought in the Nitya Meenakshi Institute a large number of projects from DRDO, DST and other organizations. Dr. Kulkarni, because patents which we have done here made in NMIT was totally paid by Technic. And thanks for his effort. He has all the time. In fact, I met him and presented the patents and he said, do more patents. Recently we have done 2013, just few months back I had the third patent from NMIT, developing a new algorithms for underwater imaging. My basic area is image and video processing, an embedded processor, and a kind of multidisciplinary research is the word of my career has grown around multidisciplinary research, starting from 30 years back or maybe 20 years back, my PhD also in an industry-sponsored project in CSIR. I started my career in CSIR, Council of Scientific and Industrial Research. Somebody spoke about it. It's one of the great organizations. I became PhD at an early age only because I worked in CSIR. Because CSIR earlier time have really promoted the PhD. Compared to that, DRDO, BRC, they did not promote that way. I'm telling about 25 years back. The CSIR always told every new scientist has to do PhD. And that's why we all became PhD, because our career started in CSIR. However it is, this particular work, I have actually brought some technical presentation, which I am going to skip. I have actually asked the organizers whether I should give this lecture, because I'll tell you what is the introduction and why it is so important. Today, micro air vehicle, it's a small aircraft which is a surveillance aircraft. I'm not sure whether you know about the defense, the aeronautical development establishment where I have worked for a long time on the unmanned surveillance program, and actually this Rashida who is sitting is one of my colleagues from the unmanned surveillance program, and we all have worked for unmanned aerial vehicle. And the various systems we have developed, intelligent systems, being the area of sensor development and the processing, and also a real-time requirement, we needed certain things to be developed, and it was an effort of 15 to 17 years of hard effort that we built some systems. They are not the best system in the world. They have all gone for trial, and that's the way, thanks to DRDO, it gave us the opportunity, all of us, to learn things, to get failure, and from the failure learn the success. So, but those aircraft on which we worked in DRDO was little bigger aircraft. We start with mini UAV and all those. But today, it is sometimes started in a very small way in the year 2005, 2006, when I was still in DRDO. A concept of micro aircraft is started with a joint effort of NAL, National Aerospace Laboratory, CSIR, and DRDO, ADE in particular, that we must build small aircraft which are called surveillance aircraft, which could, the ultimate aim is they will all go in a kind of together, they all will fly and they will do certain activity which are all surveillance activity. Advantage of this small aircraft is they are not coming on they are so small and they are so tiny, they will not come on the radar screen. That is the advantage. I have, in a very small way, inside ADE, since we are all talking about that, we started doing some very small work, not under any particular head. After my retirement, this project finally became a big government project, and the project came on 2010 when I was already in Nitya Meenakshi. And actually my first work was the satellite. 2008 I joined, 2010 the satellite flew. After that, this micro air vehicle project was sanctioned. Before that, I have taken 3 successive projects from my alma mater, Aeronautical Development Establishment. One of the major important thing of this vehicle is the stabilization. As soon as the vehicle flies, it starts falling. It falls like this or it falls like this. So how do you stabilize it? So that was the system which we developed, and along with, I don't know whether they are there, along with a group of students from my group in ADE, along with a group of very brilliant guys from IIT Delhi. And they have come with the incubation center at that time. I'm not sure whether they are here today around the audience, but with those people together, we developed the stabilization first. So stabilization, that's the time when the work has been done in micro vehicle only in small pockets, various places in US. It started Florida, maximum work started in Florida, where there is a series of work on, can you just show the slide? Series of work on, as the vehicle goes, this is a small aircraft, 350 grams. On the nose of that, you have a small camera. The weight of the camera is only 5 grams. That time it was 5 grams. Today it is 1 gram we are using. 5 gram camera, and that camera will see the horizon of the sky as the aircraft flies. And you see the angle of this horizon. By using, you can't use a big circuitry, remember that. You can't do any big hardware on that aircraft. You have to use small system. So you use light cameras which are about few grams, and those cameras are put on the nose, and then we use certain software and hardware which are developed on lighter media. So the objective of that is to find the horizon. So how do you find the horizon? It's a sky and a ground as the aircraft flies. So you have to have computer vision based algorithm to be able to find out the sky and the ground. The ground consists of buildings, water body, road, anything. So all this has to be one category. The work what we did consists of 3 different approaches. It was, just go to the previous. It was auto thresholding, texture features, wavelet features. We used all, trained a large number of such images, developed a classification system, and as the aircraft fly, we could determine the horizon angle, the angle which separates sky and ground. Once you know this angle, then you could determine, there's a mathematical formulation, you could determine the roll and pitch of the aircraft to correct it. So you calculate that, go to the telemetry data, and you change the telemetry. It has to be all done in real time. That's the challenge. The project which ADE gave was to develop the technology. Next. Now, so these are some of the results. Come to the next. Now what will happen, I want to tell you this. This is our first patent. My first patent, of course, was the satellite ground station, which was the first time a small satellite ground station. This is the second patent. The whole thing, all this technology, what I told, to bring it in hardware in an embedded circuit is not very easy. So we developed a new algorithm. The conventional algorithm takes a lot of time. Even if you put it in real time, it doesn't work a hard real time. It's a soft real time. You need a hard real time here. Think of it, the aircraft has to go and it has to continuously correct. So this hardware we developed, and this became the patent. The hardware and the algorithm suited to the hardware. Every software algorithm cannot be translated to hardware. You have to change your software to suit to the hardware so that it works in hard real time. So that was the challenge on this, and we got the patent in MIT. Next one. So these are the histories which was part of my original lecture. I thought it doesn't fit here. But let me just tell you about what is needed today in the country. Micro vehicle project, it has conventional control system, conventional sensors, conventional navigation. Nothing is applicable for micro vehicle. You can't bring to that category till 150 gram aircraft with all those systems which are conventionally available. What is needed today? This is, I thought, is the right gathering who could take forward this problem. So you need computer vision system which is developed on lighter sensors, very lightweight sensors with its current embedded boards. Let us talk about ARM board. Let us say ARM board is just an example. ARM board and the associated circuitry which are light to be able to put on that aircraft which doesn't work on conventional system. So what are the challenges here? What do you need to do in that? In order to be able to fly the aircraft, what we need is an area, that means a navigation area, which is not known to you. Navigation area is unknown. Number one challenge. Number two, the aircraft doesn't have GPS. It is a GPS denied environment, mind you. You cannot use a GPS. That put a GPS, the first thing is that GPS can be changed, the reading can be changed. It may be a part of data, it may be inaccurate data, it may be a weight which the aircraft will not be able to take. So it's a GPS denied environment. You have a small IMU system on that. Inertial navigation system is there just to start the aircraft, that's all. After that, you are supposed to fly, navigate on the terrain, which the terrain is not known to you, and total environment is unknown. That is the challenge for them today. So we want a control, guidance, navigation and landing in an unknown environment, when the terrain is unknown and the environment, you do not have GPS on the aircraft. So that is the problem which needs to be solved, and as various people have talked about, so many funded projects, so many opportunities. This is basically a project between DRDO and CSR, where NDRF, National Design and Research Forum, has come forward. They have a stake on that. And private engineering college can be given projects through NDRF. And we are looking for people who are, I'm a program management board and a review member of this project. In both the boards I'm there because of my experience in computer vision and image processing area for 40 years. So we need people who should come forward and develop this new series of algorithms. This particular system has not been developed today in the country. So I'll give a small example of these are the landing target. Some of the people started working on, they put a target on the landing area. Some design any of this. And then you could use a conventional image processing technique which is in a shape and in variants of size, moments, to find out how is the target as the aircraft is coming to the ground. Next. So then there is something, ingress. The aircraft has to enter through a window, enter in an opening in a building. How do you solve that? This is the work of one of the scientists in 2011, Bloch, he has done a lot of work on that. So he has shown certain work, how he has been doing it. So basically, I'm not sure whether I should talk about the detail of that, but one of the approach which we found, we are doing a lot of work in our college, certain work we have started, and we are in the process of taking, we are inviting people, whoever are interested to work on that, come forward. One of the approach which is more suitable in this called optical flow approach. Optical flow approach is just next. So we are just showing you, suppose there is a sequence of video, you find out from the video how the points in video are moving. Every point in the video is moving. So there are certain things called corner detector with the help of which you could find the flow of that. These are the flow of the patterns. Those are the flow of the pattern. So whenever, as you go, so you have to do two things. One is the terrain you have to map. Terrain is not known to you. So how will you map? What is your source? You have only camera. So to take camera sequence of video, so this work what is needed today is needed the technology today, video processing. So we cannot stick to image anymore. This problem cannot be solved. So from given sequence of video, first thing what is to be done is map the terrain. How do you map the terrain? So I'm not sure whether people are aware of, there are some new area of technology in video called video shot detection and video summarization. Given a sequence of video, huge video for 2 hours, can I see the summary of the video? This is one of the research which has been started in the world by a professor from Israel University called Shumel Peled, who became world famous after developing this technology in the research level. But today, this research is being used extensively by various people all over the world on various systems. So, as the aircraft is going, you have to remember that you have a very less computation power available. You can't use a huge computation power. So with a limited computation power, you cannot process every frame. So you have to use a technology where you could automatically select a summary of the frame as you are seeing them. Once you know that particular frame, you could use the next technology, the next one, just go to the next one, which is called mosaicing. That means this sequence of frame could be put together and generate a panoramic mosaic. Just one second, show the panoramic mosaic. A panoramic mosaic of the terrain. I'll just show you that. No, you have to go. So going back. Go to. Mosaic. Next. Yeah, go next. So, this is kind of a mosaic. So, as the aircraft is flying, you are creating this, the panorama of the terrain. But this panorama has to be given a geographic location, and that's the reason it is required that you register it with a high-resolution satellite image. Once you do that, you will have a complete idea about the terrain, computer vision-based terrain. I am only mentioning in the technology what is required. And then the aircraft doesn't have GPS. So you have to have a tracking mechanism. So there are two processors run parallelly. One is called tracking and another is called mapping. So the tracking will continuously track the objects as the aircraft is seized, and it has to do an inverse transformation to find out the location of the aircraft. So this is the technology which needs to be developed. There are, as you have heard about, lot of funding agencies are available in the country today. People are expected to come forward, the people who are interested in doing this kind of research, to be able to solve this problem, because in micro vehicle today, in the world scenario, it is only the computer vision system finally which will see the light of the day, of a navigation of an aircraft and control of an aircraft, guidance of an aircraft on a terrain. Thank you. I think I'll stop here. Thank you very much.